Welcome to the Fire Prevention and Firefighting lecture series. In this video, we will learn what is the meaning of sustenance, how the fire is sustained, how the fire spreads and it grows, and how to suppress it. Suppression is different than the firefighting. If the fire has occurred, how do we suppress it? These few things we will learn. It's a small video, small lecture series, just 10-15 minutes. All right. So FPFF, Basic Firefighting Course as per the STCW standards. This is the module 2, and the chapter 2 we are talking about sustenance, spread of fire, and suppressing it. Enjoy it. Introduce myself because you must know who is your trainer. So welcome aboard. I am Sanjeev Mehta, and I'm your instructor for this module on fire prevention and firefighting. With over 2 decades at sea and then in the maritime training, I worked in the training center, some of the ship management companies, and then I have been freelancing, doing many things, auditing, etc., etc. Some training, of course. So this course is designed not just to inform you, just but to prepare you to act, think, and respond when it matters the most. Fire can happen anywhere, anytime, even on the ships. And on the ship, if it happens, it's devastating. It overwhelms the crew, all right? And a fear sets in. So you have to prepare yourself. Remember, fail to prepare means prepare to fail. So you must prepare before any incident occurs. So let's begin this voyage by understanding the fundamentals that could save lives, including yours. When a fire begins, it preheats the surroundings. That means it starts heating up the surrounding material also, which may not be at fire, which make the flammable material to catch quickly, fire quickly if it is present. That means that initially the material which had caught fire, and there is a material which is flammable lying somewhere near that can also catch fire. That's how the fire spreads. The material which is not flammable becomes too hot to touch. For example, door handles. You are unable to open the door or find it difficult to hold the handle to open it up. Clothes we are wearing may also begin to burn, causing irritation and charring of the skin. If you are wearing synthetic clothes, it will become much more dangerous because a synthetic cloth adhere to your body. It starts melting. They are petrochemical products actually. So they stick to your body, start melting, and difficult to remove them. Remember, if your clothes are on fire, do not run. That will make it worse. Roll on the floor. Another person, if present, may throw a blanket or thick cotton material covering the person. Cover it yourself with that material which has been thrown to you. Try not to wear synthetic clothes when working on ships, actually anywhere. What information we get from the fire triangle explained in the previous chapter? Remember fire triangle? For the fire to begin, we need all three things. That means all three sides of the triangle must be present. What are they? Flammable material, source of ignition, and air or oxygen. They have to be present at the same time together. So do you think if a fire is burning and we remove any one element of the fire triangle from the fire which has occurred, fire will stop? Indeed, you are correct. If we remove any of the element from the fire triangle, fire will stop. This is the beginning of our effort to douse the fire. This is way we douse the fire actually. Fight, Fighting the fire is different, will be different, explained in later modules. But this is what we can do to stop the fire. Therefore, to extinguish a fire, remove oxygen or air. Because air has 21% oxygen, 20.8 actually. Remove the source of ignition, or if the material has already caught fire, reduce its temperature. Remove the flammable material. Okay. So remember, once a fire is started, these are the way we can stop it. And once a fire is stopped, remember it can reignite if the temperature was not brought down sufficiently and the fire was still smoldering. So either we have to make it sure that it's cooled down sufficiently, that the temperature is not sufficiently high to reignite it, or the if the air was cut off, do not supply air once again until and unless you have confirmed that no smoldering fire exists. So do not start ventilation again or open doors, portholes too quickly without ensuring fire actually died down and no chance of it reoccurring. Smoldering fire may reignite if sufficient air is made available again. Remember that. So remove oxygen. Air has 21% oxygen. A logical question arises. What minimum percentage of oxygen is required for the fire to begin or fire to sustain? If other two, that is flammable material or vapor, and the source of ignition is present. So what is the minimum percentage of oxygen is required for the fire to begin? What is your answer? Yes, it is 11.9. Commonly we call 12%. So it's the minimum percentage of oxygen which must be present so that the fire can begin. If percentage of oxygen is below 11.9%, fire cannot begin no matter how high is the temperature and how much flammable material is present. Understood? So this means if oxygen percentage is less than 11.8, mostly we call it 12%, the fire will not occur, even if flammable material or vapors and source of ignition is present. It also means a fire can be extinguished if oxygen percentage is brought down, reduced to 12% or below. Correct. That is why when we cover the person, which in the previous example I told you, throw a blanket or a cover, clothes are on fire with a thick cotton cloth or the blanket, we cut off air supply. Or which other example which I gave you, when gas cylinder at home is at fire, you cover it with a towel. What you are doing? Cutting off air supply, oxygen. Fire blanket in the ship galley also serve the same purpose. That's why all galley, ship galley always have a fire blanket. Quickly cutting off the supply of oxygen as soon as you throw the blanket, fire blanket. When a fire is covered with the fire blanket, it goes off. It's a good idea to have a fire blanket at home also in the kitchen. It's a suggestion. Remove the source of ignition or heat. We have learned that the heat or source of ignition is required for the fire to begin. Heat or source of ignition can be a direct flame, like when we use a matchstick to light a candle. We are using direct heat from the flame of the matchstick to burn the candlestick. Mechanical or physical action like friction. Actually, when we strike a match against the coated side of the matchbox, what we are doing? It's a mechanical interaction. A friction occurs, and friction generates enough heat to ignite the matchstick. Chemical reaction. Many of the chemical reactions are what is called exothermic reaction. Fire is a chemical reaction, exothermic reaction. Exothermic reaction means giving off the heat. This chemical reaction causes enough heat and causes a fire. Fire itself is a chemical reaction, But because of chemical reaction between two substances, sufficient amount of heat can be generated, may be generated, so that flammable vapors, if present, they will catch fire. Nuclear reaction, like which is occurring on the sun. Actually, fusion is taking place. Enormous heat is produced by the nuclear reaction taking place on the sun, where hydrogen atoms fuse together to form helium atom, giving off enormous heat. So these are the source of heat. If you remove heat, fire will not play. So we'll not talk about nuclear reaction on the sun because that is out of the scope of this course. As I just said, the item D is out of the scope, so we'll not consider that. Fire, as explained earlier, is an exothermic chemical reaction giving off more heat. So if the fire has occurred, it gives off more heat. More vapors can be generated and more vapors can catch fire. So once the fire has begun, a chain reaction continues, giving off more vapors, burning these vapors which are produced, and giving off more heat because these more vapors are burning, and it kind of becomes a chain reaction. All right. And again, remember, fire doubles every 20 to 30 seconds, doubles in size, doubles in size, 20 to 30 seconds. A quick and early action is important. The common source of ignition on the ship are smoking. Yes. Pipes carrying steam or other hot liquids and insulated lagging are broken or removed fully or partially. So those pipes which are carrying hot liquids are broken, laggings are removed. Some flavor material, like say some fuel oil or some kind of liquid, can fall on the pipes and can ignite. Electric spark, faulty electrical equipment, hot work when we are carrying out gas welding or electric arc welding is a potential threat if precautions are not taken. Using multiple plugs in an electrical socket, one of the simplest thing which can be avoided and which is causing certain accident. Number of accident has occurred on the ship because of this. We are so used to using a multi-socket uh, extension cord, which is commonly called at home. We carry it on ship also, and we use it on ship. One socket means one plug only, nothing, no more. Static electricity. You know what is static electricity? You must have seen synthetic material clothes which you are wearing when you take it out. Hmm. What happens? Your hair on the hands and all, or maybe on your head, they they rise up. Sometimes your comb, when you're combing your hair becomes erect. We'll talk about more. It's more about in a tanker course we talk about because the cargo when you're loading is flowing, oil which is loading, that also generates static electricity. Hmm. Anyway, oily racks lying around in open bin containers, potential source of ignition, potential source of ignition, because their flash point reduces drastically, and at room temperature they catch fire. Spontaneous ignition, as we call it. Even a simple extension cord with multiple sockets must not be used on board the ship. Again, a reminder. Okay. Removal of sources of ignition. Smoking, if required, must only be done in the designated smoking room only, not in the cabin. Never smoke when lying down on the bed in your cabin. Actually, never smoke in the cabin, and of course, never, never, never when you're lying down on your bed. All pipes carrying hot fluids must have their legging intact, and broken or partially removed legging for any work must be replaced soon after the work is completed. Whenever flow of current is stopped or started, a spark is invariably generated. Well, understood what I am saying? Whenever flow of current is stopped or started, current starts to flow, there will be a spark. Okay? Can be larger, can be smaller, but there will be a spark. Even intrinsically equipment, safe equipment, you have a spark. But only thing is the spark generated so low, less than two EVs, two joules. So it cannot ignite the flammable material even if present, flammable gas. That is the only thing in the intrinsically safe equipment. But spark occurs there also. So fortunately, flammable vapors are not present in most of the area. Hmm. Like in the room, when you switch on or switch off any light or any switch, there is a spark. But no flammable material is present in the vapor form in the surrounding area. In a hazardous area, intrinsically safe equipment must only be used, like on oil tankers or gas carriers. I told you what is an intrinsically safe equipment. Spark, it also generates spark, but the spark is the energy contained in the spark is less than 2 joules. Always follow the procedure and safety permit system of your company whenever hot work is to be carried out. Precaution is better. Removal of sources of ignition. So coming to static electricity, as I told you, clothes, synthetic clothes can also generate static electricity, but that is not sufficient to cause a spark or start a fire. But static electricity generated on ship when oil cargo, especially some type of oil which are called static accumulating oils, they accumulate static electricity. When it flows through the pipeline, when loading or unloading cargo, large amount of static electricity is accumulated. Earthing must be ensured to ground the pipe so that this generated static electricity does not give off a spark. Otherwise, whenever this oil, which has accumulated large amount of static electricity, comes in contact with the media which can conduct electricity, a spark will occur because it will try to jump across. So pipe should be grounded. Static accumulating oil have electrical conductivity of less than 50 picosiemens per meter. So they have very low conductivity. So the electricity is not conducted but stored in the oil. Therefore, it is capable of retaining substantial amount of electrostatic charge. Oily rags get collected on ship during day-to-day activities of the ship. In the engine room of all ship and on deck, on oil tank or many other ship, when wet oil rags are stored in a location, spontaneous ignition of oily rags may take place at much lower temperature than the ambient temperature, at much lower temperature than the temperature at which oil would have caught fire otherwise. This auto ignition occurs because the oxidation of the oil which generates heat. So how does spontaneous ignition take place? These oily rags, the oil contained in the oily rags, soaked oily rags, oxidation of oil start taking place. Oxidation. And this oxidation is a chemical reaction. And this reaction gives off heat, generates heat. Then it's possible the oily rags may catch fire. So oily rags must always be stored in a container which is closed with a lid. Definitely, positively, compulsorily. Remove the flammable material. We had learned that flammable vapor only catch fire. Any material which is capable of burning must release sufficient amount of vapor which will start burning if other two sides of the fire triangles are present. That we know. So what is the temperature at which sufficient vapors are given off by a flammable material? Let us learn a new term, flash point. Flash point is that temperature at which a flammable material gives off sufficient vapor which will catch fire if oxygen and the source of ignition is present. So the flash point is a certain temperature is important to know about various media which we are using on the ship. We will learn about some of the words and terms used in the context of the firefighting in the forthcoming module. So I will not be explaining all the terms. Only this has come in this context, flashpoint I have explained. Okay. Remove the flammable material. Different flammable material has different flash point. For example, flash point of petrol is -40, and for marine diesel engine, it must be more than 60 degrees centigrade. This is a mandatory requirement. On board the ship, fuel which we use for ship propulsion or energy generation, that is power generation, electricity generation, fuel must have flash point above 60 degrees centigrade. This is mandatory requirement. For wood, flash point vary depending upon its moisture content and the type of wood. Typically, flash point is between 250 to 300 degrees centigrade. So, I hope you find the lecture series interesting and encourage you to learn and look forward to more of the videos. Do spread the word amongst your mates on ship, ashore, also to your company. So this is the end of module 2, chapter sustenance, spread of fire and suppressing it. Not firefighting, suppressing it. Shortly, I will prepare chapter 3 of module 2, and in chapter 3 will be, as I was telling you, some definition, relevant definition and terms which are used in this course will be explained so that you understood the meaning of those terms before we proceed further. Meanwhile, learn also what is Guru Dakshina. Who is a Guru? Guru is your teacher, trainer, instructor. What is Guru Dakshina? It is a voluntary contribution as per the wishes of the disciple and is offered to his Guru on his or her own free will after he completes his learning session. All right. So if you so wish, this is my PayPal address. PayPal payment, you can make it here. It's voluntary. Remember that. DCEPROF. What is that? Delta, Charlie, Echo, Papa, Romeo, Oscar, Foxtrot. So PayPal, you can go, you'll find this DC Prof and you can make it. Okay. Thank you very much. Have a good day.